Hello, everyone. My name is Xiangzi Li. I am an applied scientist at AWS. Today, I'm presenting my internship work at Amazon. Wizard of Shopping target-oriented e-commerce dialogue generation with decision tree branching. Traditional product search relies on the customers to have direct iterative interaction with the search engine to refine the results from the overwhelming candidate products. And if customers are not familiar with the product categories, they have to spend significant amount of time to study and filter the products. Conversational product search, shortened as CPS, searches users' desired products with a conversational interface instead of the traditional search box. Till now, there's no large-scale human-like CPS dataset yet, presumably because the commercial interests of the e-commerce platforms and the privacy concerns. In this work, we aim to create synthetic conversations with the LLMs to train a conversational product ranker. Note that in this work, we do not aim to build a chatbot here. The figure on the right illustrates the setting of this work. There are two parties talking to each other, the customer and the seller. If you are familiar with the wizard setting, then the seller corresponds to the wizard with the access to the product database, while the customers do not have the access to the database. And we assume the customers initially only knows the product category to purchase, and the seller tries to narrow down the search condition by uncovering the product features that the customer wants or does not want. We also assume each product is associated with multiple features, essentially aspect value pairs. For example, in this example, the customer starts with saying he or she wants to buy a lipstick. And the seller figures out the first question should be about the color of the lipstick and offering example colors such as red, black, or clear. The customer chooses the dynamite red option. And then the seller further figure out the next question will be the form of the lipstick, such as in cream, stick, or liquid. In order to create such a CPS dataset, there are a few challenges to overcome. For example, how to use the knowledge in the product database to narrow down the products quickly. Because there are thousands and millions of products and features in the database, it's not possible to consider every possibility. And how to control the LLMs to generate the conversation that we desire is also challenging. In this work, we use decision tree to make product search dialogue plans for both seller and customer and use LLMs such as GPT-4 and Llama 2 to generate CPS conversations. Here's the approach we propose for CPS dialogue generation. We randomly sample gold customer preference, taking lipsticks with dynamite red color as an example. The customers start with saying he or she wants to buy the lipstick. And then we iteratively use decision tree to figure out the best product aspect that maximally divides the search space. For example, we find that the color should be red, and then the form of the lipstick should not be liquid. After the search converges, then we recommend one of the qualifying top K products. In this way, we predetermine the conversation plan, and the rest of the work is simply just asking the LM to role play according to the plan. In our implementation using LMs in 2023, we find generating the full conversation in a single pass more effective than asking the LM for generating the multi-rounds of conversations. However, we suspect that an agentic approach may work better in the latest LLMs for 2025. Here's an example generated conversation. The conversation plan is listed above, and the actual conversation generated by the LLM is shown below. Using the approach introduced previously, we collected 3.6K conversations using GPT-4 single-pass approach across 3 domains: electronics, home and kitchen, and beauty and personal care. We directly use human evaluation to evaluate the quality of the generated datasets. We use the following metrics. For the conversation level, we use realism, conciseness, coherence, and overall naturalness. For the utterance level, we use the realism and the script following as the metric. As you can see from the tables on the right, the GPT-4 with single pass generation approach works pretty well, achieving more than average score of 4 for all the conversation level metrics. For the inter-annotator agreement, we also obtained moderate to high agreement for both conversational level and the utterance level evaluations. Here is a detailed breakdown of the human evaluation rubrics. Note that the naturalness of 5 means indistinguishable from the human conversations. This implies that the conversations we generated is close to the naturalness of the human conversations. Finally, we evaluate the conversations we generated on 2 tasks: conversational query generation and the conversational product ranking. Conversational query generation is essentially the reverse problem of the conversation generation problem. And for this, we use a long-former encoder-decoder model as our main model. As the table above shows, the LED model trained on the Wizard of Shopping dataset significantly outperforms both the weak baseline and the GPT-4 baseline on the conversational query generation task. This further resulted in a significant improvement on the conversational product ranking performance. Therefore, here we successfully showed that by training on the Wizard of Shopping dataset, we can significantly outperform the baseline. As a conclusion, in this work, we propose a shopping domain-specific method to automatically generate the target-oriented shopping conversations without any human annotations. We leverage the decision tree to explore the vast product search space and construct a dialogue plan that minimizes the number of search steps required to retrieve the relevant product. The resulting corpus showed substantial improvements when applied to 2 downstream tasks. By releasing our dataset and the approach, we hope to expedite the research and development of intelligent CPS systems in future.